In this video, we're going to continue topic 5 or 8.1. We're looking at exponential functions, and we are going to use our graphing utility in examples 15 and 16 here to find the points of intersection, if any, of the graphs of the functions. So I'm just going to go straight into graphing those functions here. So I'm going to go to Desmos, and you can use f equals. I'm going to use y equals, doesn't matter. So it was 100e, and again, I hold shift 6. To the 0.01x. And you'll notice I'm not seeing anything, so we're going to find it here in a minute. And then we're going to have y equals 12,500. And again, I am not seeing that anywhere. Oh, it doesn't like the comma in there, so take the comma out. There we go. So I don't see anything on my graph. I'm going to scale my graph. So I'm going to come over here to the graph settings, the little wrench, and I am going to adjust a bit. I'm going to adjust. I don't know that I'm going to need my x-axis more negative. I'm going to go more positive. So I'm going to make this like 500 just to see if I can find my graph here. And I'm going to make my y-axis go. I know I've got that 12,500 number, so I'm going to go up to 13,000. And I see some things appearing finally. It looks like I'm going to go a little bit higher. I'm going to go 15,000, so I get that centered a little bit better in my graph. A little bit better. Oh, I'm not far enough on it's hiding behind my settings, so let's try making this setting on the x like 700. There we go. That's a little bit better. So I noticed that my point of intersection here is 482.831 and then 12,500. So that's really all we're doing is just reading the point of intersection off of the graph on that one. So there isn't a whole lot. Probably what you could do to prove that you've put it in your calculator is draw a little sketch so we know it looks like this. And then our point of intersection is 482.831 and 12,500. And then in example 16, we're supposed to graph the function and then use the graph to find increasing, decreasing, and approximate any relative maxes or min values. So I'm going to X out what's there, and I am going to graph this. So we've got f of x equals 2x, and then I'm going to hold the shift 6 for my exponent squared, e, and then shift 6 again to the x plus 1. Oops, plus 1 needs to be in the exponent. It's not sticking, is it? Let me put parentheses, x plus 1. There we go. And I definitely need to reshift. I'm just going to hit the home button. There we go. So now we've got a good picture of our graph. Notice it kind of automatically puts some values in there for you. It actually gives us our max and our min value in the graph there. I'm just going to hit a print screen and see if I can get that into my notes here. So let's see if it'll let me put that off to the side. It is super gigantic, but it'll work. So I can scribble on it a little bit. So we're supposed to look at increasing, decreasing. I'm just going to scribble it here, but I would put this, if I were you, I would put it up here in your notes, okay? So put it on example 16. I would start by sketching that picture in my notes really quick and then labeling these 2 points on it. So the B was, where is it? Increasing and decreasing. So increasing means that from left to right, I am going up. So it looks like I'm increasing here, which I don't really know where that starts. So if we don't know where it starts, we're going to say negative infinity. And then we're only going to go x value. So it goes negative infinity to -2. And it increases from 0 on up. And technically that could keep going forever. So we could say that it goes to infinity. And then decreasing, let's use a different color for decreasing. Decreasing. So decreasing is where from left to right it's going down. So it looks like it's decreasing from the x value of -2 to the x value of 0. Then it's asking me in part C, where do I have maxes and mins? So my max is obviously this hill. It's a hill point. So my max is at -2, 2.943. And then my min is the valley. So my min is at 0, 0.